You have seen transformations before, but let's go through quickly what they are and a reminder about them. This will be a quick review of this page before we do the problems on the next one. All right. Horizontal and vertical shifts are the same idea. You have a graph of a parabola or something, and horizontal shifts go this way and vertical shifts go this way. It's just the same shape, it's just moving around. Ends up being a diagonal sometimes, but it still moves that way. So on a vertical shift, in fact, let's start with a parent function of y equals x squared. We'll do a parabola. That's the basic parent function. Now, I'm going to do a horizontal shift, and I'll show it this way. What I did is, with the x inside the squared part, I put a plus 3. That location alone is what it is that determines what you do. If it's with the x, you consider it a movement of -3, the opposite sign. So here, I'm at 0, 0. I would move over this way to -3. And what it's saying is move everything 3 spaces that direction. So even though it's a plus, it's actually the opposite sign that you do. You move everything 3. So this point goes over 3. This point goes over 3. This point goes over 3. That point goes over 3. And I end up with the parabola going this way. So the parent function moved over 3. If it had been a y equals -3 squared, y equals x minus 3, or -3 squared, then I would have moved it the other way. So I do the opposite sign for this. So make a note for yourself, opposite sign, opposite direction from what you would normally think. Most people would think +3, we're going to add 3 and move everything that way. Not if it's on the inside. But it is true for the vertical shift. So let's do y equals x squared. Now we'll put a +3 in a different place. So the +3 goes here. Okay. So what we do now is the parent function, and I'm just going to do a dashed line for the parent function to show there's the original one. What the +3 does is it moves everything up 3. It actually goes plus. So it goes up to 3, this one goes up 3, so it's going to look something like that. You can just estimate it for a parabola. So the function goes up 3. If it had been a -3, it would have gone down 3. Now, reflection over the x-axis. That is when you simply have a negative here. Now, what that means, remember exponents come before multiplying. That really means it's -1 times x squared. So if I were calculating numbers, and if I put a 4 in here, 4 squared is 16, times -1, I'd have a -16. All right, so you have to be careful about that negative. So what that does, parent function goes here. There's your parent function. The negative flips it, so it's simply going that way. Anytime you see a -x squared, it means it's opening down instead of opening up, automatically, every time. This one, though, is different. It's not very common, but I've gotten questions about it before and wondered myself. And here's what happens. You flip it over the y-axis by doing it like negative inside, so it does get squared. Here's the problem right now, guys, right? And pay attention here. Okay? Go outside if you need to get water or something like that. Okay? You need anything. So the -x here, well, I have a parent function going like that. When I flip over the y-axis, it won't be any different. You can't tell the difference. So I'm going to do this. Instead of that one, I'm going to do y equals -x plus 3 squared. Well, what that does is you would have it where it's the x plus 3, which would be like this. That's the one that we did here, x plus 3 squared. But the negative here is going to flip it over the y-axis. So it's going to come to here. So this thing just flips over. It looks like it actually moved 6 units. Okay, that's coincidence there. What really happens is that each point here on this has now flipped over to this point here. And so it's like mirror image. It's not as common. This one's much more common. So you won't see that very much because of the changes on the inside. Okay. Now, because usually we'll do something else like have a -3 instead to move it that way. So it's more common to do that. Stretching it is, think of a rubber band, and when you pull it, well, a rubber band like this, so you pull it and it stretches out like that. So it actually makes it like thinner. Whereas the shrink, this one here, will make it open wider like that. And that's where it's the number on the outside. Let's do, I'll do that 2x. If I do y equals 2x squared, here's the parent function. And it's going to make it go on the inside like that. It's going to make it go up faster. Because every time I put a number in for x, say I put a 5 in there, 5 squared is 25, but then I'll times 2, so instead of a 25, I'll have a 50 for the answer. So that means the y is becoming a lot larger, and that means you're going up farther to get to the y for it. Now, it's different if I do a fraction, 1/2 x squared. Every time I get a number here, the 1/2 is going to cut it down. It's going to cut it in half. So that means the graph will not grow as fast. It won't go up as fast. So here's the parent function. And a 1/2 is going to make it go like this. Maybe not quite as pronounced, but you get that idea here. It's going to go out to there. So that's a big thing to think about. The 2, you would think makes it bigger. And to some people, this is a bigger thing, but it really isn't for this. It's going up slower. So it opens up like this. So if the number is a fraction like that, that's what we do. Well, it's a fraction less than 1. 3 over 2 is a fraction, but that's larger than 1, so that would actually make it more like that. Okay, so instead of saying fraction, you say a number less than 1. Those are the basic transformations. You're going to move left or right, you're going to move up or down, you're going to flip over one of the axes, and you're either going to stretch it or shrink it. You know? So, look at the next page, please. I just told you each one of the transformations one at a time. This equation has all 4 of them. Originally, because it's an absolute value, it would look like this. But you have a negative, and you have a multiplier, and you have a +1, and you have a -2. You have 4 things happening there. Your job is to tell me what they are. Right? So describing them would be saying, well, what are these 4 things? One of them's really easy. What's the negative mean?
Reflection.
Reflection? Over what?
In this case, it would be the x-axis, right?
It is, because it's on the outside. And that's why on the page before, it shows you for each of these things, if it's on the inside, it's moving this way. If it's on the outside, it's moving that way. If it's negative, flips over the x-axis. Negative inside will make it flip over the y-axis. Probably not going to see that much. A number greater than 1, a number less than 1. So here, the negative means it's going to reflect over the x-axis. What's the 4 do? What's the 4 mean? Think back about what this picture shows. When there's a number on the outside, what's that?
Is it like where it is on the x? Is it -4?
Nope, not where, well, it does change where it is, but look, let's look back here. When you have a number on the outside, like this 2,
Yeah. Oh, it'll affect the.
yep, it'll affect the shape of it like that. So it's a stretch. It's going to stretch it by a factor of 4. This would be a stretch by a factor of 2. So the way to say that is stretch by a factor of 4. The negative is separate for the purpose of these transformations because it does something different. The negative makes it reflect over the x-axis. The 4 stretches it. And factor means multiplying it. So it's multiplying by 4. Now let's look on this inside. When you have a number on the inside, you're moving left or right, horizontal, but it's the opposite direction of that positive. So that means you would be going like this one went this way. That means you're also going that way. That's to the left. So it's move 1 unit to the left. And that's how you would say that. And this one's actually, I guess the negative is the easiest when you just remember it reflects over the x-axis, but this one's pretty easy too. What's the negative 2 on the outside tell you to do? Take back the picture of where it'll go. Yeah? Goes which way?
Wouldn't go down to?
It would. The negative would tell you to go down. So it's going down 2 units. So 1, 2, 3, 4 things, and these 4 things are what's happening. The next problem, I have you do the exact opposite thing, where I tell you this and you make the equation. But if you think about it, you do the same thing. Now, here's one thing. This is an absolute value. I mean, this one's what's the word? Square root. Square root 1. I could have done the same thing if it was negative 4 x plus 1 squared minus 2. That would be, whoops, running off the page, sorry. That one would be the same things here. It's just would be with a parabola instead of a square root. I could have done it with an absolute value. And it would have been the, not squared on this one, it's just absolute value. It would have been the exact same things, but it would have been with absolute value. So in any of those functions, it's the same transformations. Well, this one says absolute value, so you're going to do these transformations, you're just going to start with the absolute value of x. So starting with that, think about where you would put this and actually write it up and do it where it moves 2 units to the right, moves down 5 units, stretched by a factor of 3, and reflects over the x-axis. Write it out yourself right now. Take about 1 minute, because if you think about it, you won't need more than that to just put a negative and put the number and put the number and another number.
If I reflects over it, does that mean it like goes up?
Yes, so for an absolute value, because it's reflected, it usually is like that. This one will be going like that. It'll be going down. Where exactly it is going down, that's what the other ones do. These tell you where. You don't have to graph it, you just have to make the equation. So I want this with the 2 and the 5 and the 3 in it. I want those things in it. So go ahead and try to write it, and then I will show you it in a moment here. For now, it can help to refer back to the little graphs on the first page, just to see, this is what happens if it's, numbers on the inside or the outside, what you do if you're reflecting or stretching or moving up or down or whatever. You can't do that on the test, so you want to get good enough at recognizing these things, what the words mean, what to do with it, so you can write it yourself. But for right now, use a reference. Okay, now let's look at this. It moved 2 units to the right. That's this part. If it's moving right or left, then the number has to be with the x inside the thing, whether it's absolute value or square root. It's moving down 5 units. That's the minus 5. It's stretched by a factor of 3, so it needs to have a multiplier outside. And reflecting over the x-axis means it's a negative. So this one has all 4 of these things in it. Has the moving 2 units, down 5, stretching by a factor of 3, and reflecting over the x-axis. You don't always have all 4 things. Sometimes I do problems like this where there's just 1 or 2. Or I might not have this or this. Or I might have just the x in there, and you wouldn't say then that it's moving horizontally. Okay?